लैपटॉप से करना इस पे सर फिर कैसा आएगा? या तो वो लिंक पे क्रिएट करके अपने से प्रेजेंटेशन लैपटॉप पे दे दे, हम यहाँ करें। हेलो हेलो, अरे उधर से क्यों नहीं आ रहा? आप उधर से नहीं आ रहा था? अच्छा अच्छा अच्छा, हाँ, गुड मॉर्निंग एवरीवन। presentation will start within 5 minutes. तो ट्रेन में जाना है इसमें, टिकट अवेलेबल नहीं है।
So, welcome all for this very interesting and important lecture. And today, Professor Ashish Sharma is with us. Shall give a brief introduction of Professor Ashish. So, Dr. Ashish Sharma is the Climate and Urban Sustainability Lead at the Discovery Partners Institute, University of Illinois System. And he is a faculty in the Department of Atmospheric Sciences at the University of Illinois Urbana-Champaign. He holds a joint appointment as a climate scientist at Argonne National Laboratory, and he is the director of NSF-UKRI Joint Funded Global Center on Clean Energy and Equitable Transportation Solutions. Dr. Sharma has expertise in atmospheric sciences, focusing on regional climate and air quality and assessing adaptation and mitigation strategies. Through his collaborative research across science, engineering, social sciences, and policy, he studies environmental justice issues, including heat, fog, air quality, and high impact weather. So, I, on behalf of Director General of Meteorology and IMD, welcome Professor Sharma and invite him for this lecture on climate science to actionable urban solutions.
Okay, thank you, Dr. Soni, and thank you, DG sir, for the kind invitation. I'm going to give you a very high-level overview of what we do in climate space, and especially related to urban sustainability. And okay, do you want me to sit and talk, or do you want me to stand and talk? Sitting.
It is left to you, but if you sit,
okay, so I'll sit then.
Otherwise,
okay. Okay. Awesome. So, and if you have questions, I think feel free to ask me in between, because I'll be showing a lot of animations and slides, and so I want it to be a little bit more interactive if you want, and ask me as you feel comfortable. So this is just an overview of what we do. I lead the climate ecosystem at Discovery Partners Institute. It is at the University of Illinois Systems level, where we have really strong roots in climate science, and we work in different areas, as you can see. We work on applied research. Of course, we do a lot of fundamental research work. We work on environmental justice, policy, industry applications, and so on, and as well as education as well. So there are different arms. So please do visit our group website here to see what all we do. I'll directly go into the work that we do in the urban systems. This is the article that we wrote a few years back that just shows our vision of how we want to understand urban systems and how do we see them as. So I'm an atmospheric scientist by training. My expertise, frankly, lies here, urban resolving modeling across scales and understanding the questions and the issues here. But if we really want to contribute to the urban climate science, we really need to understand the whole pipeline, looking at urban drivers, how it changes from global to local scales, and you can see there are multiple drivers of change, okay? At the same time, eventually looking at impacts, risks, and vulnerability, as well as outcomes and solutions. It has to be a very integrated vision and an approach when we want to look at sustainability and resilience in a system. Of course, we come with our own expertise and we collaborate on different areas with others. And I'm going to give you some flavor of how we collaborate and what we do with as a group and as a community of scientists and stakeholders. So as an atmospheric scientist, just to give a brief outline of things that we do, we work on bridging urban scale. We do a lot of multi-scale modeling, looking from global to regional to local, as well as hyperlocal scales. We study effects like heat island effects, lake breezes, heat waves, and air quality, especially related to urban areas. We also take urban modeling really seriously, where we do extensive data simulation, subgrid variability, and those kind of assessments. and then with the goal of studying urban meteorology as well as air quality, and especially looking towards forecasting. We really want to mitigate climate change. So we have a lot of focus on different interventions, which could be green, cool, or photovoltaic rooftops, as well as looking at energy consumptions and vulnerability analysis at the system scales. We work with stakeholders and policymakers to develop climate action plans and policies and do a lot of transdisciplinary research. At the same time, we have different focus areas as well, where we are really trying to understand how does urban heat and crime, for example, these new social dynamics that happen within the urban environments, how do they come into effect, and what are the relationships? And we use machine learning kind of approaches as well as into different areas. Okay, here. This is just building up my talk. I would like to say what happens during a daytime environment and a nighttime environment. As you can see, as the sun rises, because of vegetation, cloud cover increases, some of the radiation is blocked and some of it is reflected back from the clouds. And the radiation that is blocked really is trapped and creates greenhouse gas effect. Okay. And then over the built environment, we have buildings, we have at times high albedo or low albedo of surfaces, and radiation gets trapped within the urban canyons. We have other issues. We have roads, vehicles, ponds, and urban vegetation. Urban vegetation leads to an oasis impact, while impervious land leads to a drying impact. And at the top, we have entrainment from the upper layers of atmosphere. Okay, so overall, the maximum temperature over urban areas is higher in comparison to the rural areas. So there's not that much difference between the dynamics that happen over urban areas and over the rural areas when the maximum temperature when we are considering the maximum temperature. While during the nighttime, and this is like a general analysis, it doesn't mean every time this happens. In the nighttime, cloud cover and greenhouse gases reduces outgoing radiations. Okay, again, the long wave is trapped because of that. The minimum temperature, we are really interested in minimum temperatures during the nighttime, increases faster than the maximum temperature. While over urban areas, the radiations are trapped, and you can see the building starts emitting radiations now. So you can see buildup of urban heat island concepts during the nighttime because the buildings and the built infrastructure is emitting heat right now. So entrainment happens. And effectively, what you see is the significant increase of nighttime temperatures in comparison to the rural areas over urban areas. And that is the primary mechanism that leads to urban heat island effects, which is generally a nighttime phenomenon. And also, second concept is the diurnal temperature range, the maximum daytime temperature and the minimum nighttime temperature. What we are seeing is the diurnal temperature range is reducing as we if you look at last few decades. So these are kind of basic phenomena that happens over urban areas during the daytime and nighttime. If we look at from a systems approach, you can see a lot of issues related to flooding, heating, housing, marginalization, gentrification, jobs, green spaces, and you can name many, right? There are a lot of issues which are social as well that happens over urban areas. I have shown this figure many times wherever I go, and I can't play the animation. Basically, this is an infrared movie that shows, okay, just a reminder to all of us that we are part of the problem as well as part of the solution. Because as you can see, we have increasing the built infrastructure so much that it has become now a problem. How do we manage that? At the same time, the increasing urban population that is in cities, that is also creating a lot of toll on the urban environments. So as human body metabolism, the heat that we generated, that also contributes to urban heating. And if we look at, and a lot of examples I'm going to do relates to Chicago area, but those the lessons can be inferred to other areas too. So if you look at the current urban environments, it's very stressed. And this is true, frankly, everywhere. We have a lot of energy stress, we have a lot of heating stress, and a lot of emissions. And that translates into human behavior as well. You can see people are very unhappy here. Crime rates are higher, the green areas or natural vegetation is lower. And what our vision is, what our utopia is, we want resilient urban environments with really adaptive choices. We want less heat stress, improved air quality, low emissions, more urban greening, and a lot more happy communities and people. So this is what we want. Okay. To achieve this, this is the kind of things that we do. Okay, and I'm going to tell you what we are doing in those areas. So overall, if you look at urban systems are multi-scale, interdependent, social, natural, engineered complex systems. It's not as it's an India Meteorology Department, it's not just a physical behavior, physical sciences aspect that we have to look when we are to make a change in a society. We have to look in a very multifaceted manner. As an atmospheric scientist, we are really interested in improving the urban boundary layer processes, okay? But at the same time, we are really also interested in fundamental and translational research that we can do that uses science to serve the society. So if you look conceptually, there are two things that we are doing. We are bridging urban scales. That's as an atmospheric scientist, there are different phenomena that are much more dominant at different scales. At city scale, you can think of the mixing layers and the plumes that happens in the environment. While at local scales, you can think of the roughness sublayer, what happens to the urban canopy layer, and those kind of phenomena. While when you look at micro scale, you are really interested into what happens within the urban canyons. Okay, and then the most important scale is the human scales. Okay, what happens to the thermal comfort? How do people perceive heat and air quality at those scales? So and how does that feed back to the system as well? So we don't want to see a one-way interaction. We want to see a feedback loop. When you think of these problems, you need to have tools. So at times people have resources, at times they don't have. So when we need to really push the science, we need to have tools which can be as complicated as possible, which uses high performance computing, but as simplistic as possible that can be used to make some decisions. So we need complicated tools to train simple tools as well. And then if you look about these issues are different at different scales, at different cities, which are in different spatial scales. So you need these tools to work really for small cities, small rural communities, as well as large metropolitan areas like NCR here. Now, vertical scales. We are really also interested in vertical scales. Of course, and as I think a lot of people here are interested in atmospheric and land surface interactions, how land surface interacts with the atmosphere, and how the atmospheric boundary layer processes impact what happens over the land. So we do a lot of analysis at that scale, but also we are also very heavily interested in land surface and subland surface interactions. How and what can be done so that you can have much more improved coupling between meteorology and biogeochemistry as well. So I'm going to give a few examples as we make progress today. So if you look at climate models, as you might know, there are a lot of scales that we work in, and this is just another example to put it in a different perspective. Of course, we work at regional scales, where this is the Chicago metro area, this is Lake Michigan, part of the Lake Michigan that you see here, and then from that area, we are doing much higher resolution simulations over city scales. And when we go down to city scales, we stop using the gridded products, we go down to census tracts, because that's where the information becomes a lot more useful for communities to digest. Okay, and eventually we really go to neighborhood scales. Okay, then we think these are the building blocks, and these small dots are trees. This is predicted mean vote. What does communities feel at those scales? How the wind distribution is, how the temperature distributions are, where the hotspots are at those scales, so that we can really work with urban planners and designers to come up with new buildings, infrastructure, or to even plant trees where they need to think about those things. So there are different questions at different scales that become much more important, and what questions you're trying to answer, you design your experiments based on that. Talking about urban heterogeneity, I had a few discussion in the morning of the challenges that we face here too, and everywhere in general, to capture a lot of things that are happening within the urban environments and within the city, because our urban environment is too heterogeneous. We proudly say when we work at 1 kilometer resolution that we are working at a very high resolution. But if you look at a 1 kilometer grid box, or if you just look at the IMD facility here, you see a lot of variability. You have 8-floor buildings, you have vegetation, you have 4-floor buildings, and you have a single-floor buildings as well. So you see a lot of heterogeneity within this campus itself. So how do you measure that and make sure you are accounting that, which to be frank, it's really next to impossible when you're looking at even a kilometer resolution. So there are different processes happening at that resolution. We really are interested in understanding at that scale and inferring from that. Everyone knows of the concept of urban heat island. Like urban environment is in general hotter than the rural environment, but we are really more focused into urban heat islets, because if you look at urban area itself, there are pockets within the urban areas that are much hotter or cooler. So the distribution is there. So how do we understand that? And then you can scale it for the whole region. So that's what we are working towards. At the same time, if you look at regional interactions, like for example here westerlies and the interaction that happens with the Himalayas and the Indo-Gangetic plains and the Arabian Sea and the Bay of Bengal and at the Deccan Plateau. So how does it becomes very complicated as you're trying to simulate, say, winter fog or other atmospheric events that impact, say, NCR region. So this is an example what happens over Midwest near Chicagoland. This is the cross section of the Great Lakes. So we have lakes here. Just want to show you an example. We have river flow happening into the lakes, or at times outflows happening, interlake transport. All the great 5 lakes transport water from one lake to another. So there is not just there's a lot of things happening. While if you look at in the winters, we get the winters are too harsh in Midwest. We get snow. We have extreme lake effect snow. Arctic outbreak happens. Jet streams flow in this area, and at times evaporation. Oh. Oh wow. Okay, so at times, because of the lake stratification, the evaporation also happens, and that intensifies and produces lake effect snow. While during the summertime, you see a lot of summer urban heat island effect, summer heat wave, which are regional in scope. Lake breeze is a lot more stronger. We have moisture coming from the Gulf, from the teleconnections, and also localized convective storms as well. So a lot of dynamics happens within the area. So we are trying to understand those kind of interactions. This is just an example of how urban heat island, which is a very localized and at a near surface phenomena, interacts with the heat wave, which is quite regional. And just showing an example of temperature distributions at O'Hare Airport, where you can see really strong heat islands over the surface each day, and then large scale heat wave happening over in the top of the boundary layer. So I'll not speak a lot about the physical processes and how we measure them and how we quantify them. I'm here to talk a lot more about solutions and what approaches do we take to model the solutions. So what solutions do we have? As I highlighted, we are really interested in a lot of solutions which are nature-based. So green rooftops, white rooftops, photovoltaics, trees over urban areas. How do we make sure we can have those kind of solutions? This is just a few examples of green rooftops, urban forests, permeable pavements, photovoltaic rooftops, electric cars, and cool rooftops. When we talk about solutions, we can't think of one solution. First of all, it's not good, and secondly, it's not feasible. So we need to have a mix of solutions. So we're really focusing on technological, engineered, and ecological mix of urban solutions. And a lot of motivation comes from the Chicago Region Climate Action Plan that we co-authored in 2021. And generally, urban planners write these kind of documents, but this is for the first time non-urban planners came together to look at how can we look at the region, and we were quite acknowledged by the planning associations of the kind of report that the team produced. Yeah. So another approach is we are looking at in a very holistic fashion these kind of solutions. So if you look at this picture that shows, okay, we have end users. So at times you are city officials, government officials sitting right now here, but you also play a role of residents as soon as you're out of offices. So how can we take different roles as actors when we make decision making? Okay, smart city systems. infrastructure that the city has, vehicles, energy transfer. This is mostly related to vehicle, the vision that we have. We're really interested in integrating data science, cybersecurity, safety, policy and health economics, and how can we rope everything under the climate change umbrella. So these are the solutions that we are interested in. Of course, the solutions should benefit the larger ecosystem. We should invest in larger clean energy sources, nature-based solutions, decarbonize energy and transportation sector, and promote public transportation, enforcing regulations on emissions from industries and vehicles, which is happening in some ways here too, with using GRAP policies and long-term policies, nature-based solutions, heat and air quality and flooding impacts that they have. And of course, on urban planning and urban design, especially related to urban landscape. So I'm going to take you through a journey, few of the solutions and how we look at them. So first is the photovoltaics, right? So this is just a schematic where we talk about conventional roofs. This is the photovoltaic panel, and these are the cool roofs. And just one slide to show, okay, when we look at our Chicago region, we try to model these kind of solutions, and this is just the photovoltaic rooftop production potential. So if we aggressively use photovoltaics, what is the potential for producing energy with those solutions? And how much energy can be converted so that we can reduce the air conditioning consumptions, which the buildings use a lot. So we see a lot of potential in decreasing air conditioning consumption as well. So what the message is, these kind of solutions, of course, will change and modify the boundary layer height and structure and reduce the temperatures, but also produce energy as well. So they have dual benefits. When we talk to communities and policymakers, we need to translate these metrics in terms of CO2 offsets, for example. How much is the CO2 offset that you will have when you use these kind of solutions? Because messaging is quite important when we talk about it. People will not interpret your science in the same way that you are interpreting. You have to interpret and convey it in the sense in which they understand. Likewise, there is another metric as how many cars can be off the road when you use this. So that's another way of communicating the same outcome. So we use different metrics, different methodologies to convey these kind of outputs. Another example is with green and cool roofs. Chicago is a leader with respect to the green roofs in US. This is a conceptual framework to show how the green roofs and to show how green roofs and cool roofs work. Green roofs work on the principle of converting sensible heat to latent heat, while cool roofs use the reflectance as albedo so that the heat is transferred. The shortwave radiations is reflected back. And this is just an example that we have a lot of potential that we can see when you use green roof. This is the reductions in roof surface temperatures, and this is the temperature reductions within the boundary layer height at one point that we are showing. So the temperature reductions not only happens over the surface, but it is translated within the boundary layer height up till 2 to 3 kilometers, as you can see. Just an example over 3 days of simulations. But if you look at these results, you'll say, this is good, we should add these things, right? But now I'm going to show you that how the trade-offs matter. So again, this area, I'm taking cross-section from here, A to B, okay? And I'm going to show you what happens here. When we look at, and we are plotting here the vertical velocity here. So this is with conventional roof from A to B. Half of my area is rural and half is urban. You can see this is my vertical velocity contour plots, and my solid red line is my PBL height. And this is with green roofs, again the same plot. What you're seeing is with using a lot of green roofs, you can see you're reducing the PBL height because it's not that hot. And also the convective rolls that were going updraft and downdraft, the intensity is much lesser and it is not reaching that much height. So there is not that much updrafts happening, and the downdrafts are also very broad. So what's the outcome? So the outcome is, if you have a lot of pollutants next to the surface, they'll not be lifted up, right? So that's what we are seeing. Also, we are next to a big water body. So we have lake breeze, and lake breeze works on the principle of pressure change, pressure gradients, high pressure to low pressure. So over urban areas, we have a low pressure, and because of the pressure gradient, the breeze occurs. And if you're reducing the temperature considerably, then the lake breeze intensity will also reduce. And once the intensity reduces, you can see the advection will also reduce. So in some ways, you are reducing the convection, and you're also reducing the advection. So that's not good for pollutants. So now the question is, what is important? This is transport processes, right? So convection, advection is transport processes. What is important? So we ran some chemistry simulations, and then we started looking at chemistry behavior too. So what is the impact on photochemistry as well? And we saw that our hypothesis was kind of true. When we use conventional roofs and we use green roofs, our pollutants were a lot more settled near the surface. So it was not really good for the environment if we aggressively do that. It doesn't mean that this is a wrong solution. What it means is you can't aggressively use it, because you need to make sure you have good enough convective rolls there so that there's a lot of mixing happening. So the question becomes, where do you find those strategic locations where you implement those things so that you can have good, well-mixed urban boundary layer and take advantages of these solutions at the same time? Okay. So I hope the message is conveyed. Okay, how aggressively implementing a solution can be dangerous. Now I'm going to give you another example on urban vegetations. So we were talking about rooftops earlier. We all talk about urban heat island effects. We are very interested in CO2 dome too, CO2 effects. We talk about carbon neutrality, carbon sequestration. So if you look at plants and trees, so in different meteorological conditions, different things happen. And just giving an example, this paper was just published. You can go and have a look at it. What happens during normal conditions or heat wave conditions, or heat wave which are dry or moist, or if you do excessive irrigation? How does these things translate into CO2 sequestration? So we did some analysis. This is when there are quiescent conditions. This is the net ecosystem exchange. So we see a lot of carbon sequestration happening, which is good. But there are time scenarios when it is not great. So what we did is we wanted this kind of information to be translated so that communities and people can use it. So we created an environmental benefit score where we divided the region into different zones. And based on those zones, what different environmental conditions are, communities can make a decision to use to do things like should they irrigate their lawn or trees or not, so that they know, okay, how will there be a lot more CO2 emitted from these plants or not. So we are taking that approach. We are take a step forward from the fundamental science to come up with solutions that can really help communities. Now, I've been talking about city scale for some time. I want to talk about scales that matters. If you look at it as an individual, like I'll say, I don't care about what happens at the city scale. I care what happens at my neighborhood scale, at where I take an evening walk or a morning walk, or when I go to commute, right? So what we have, and so sorry, the animation is not working, but this is a nice animation that shows that we have 1 feet resolution morphology for the whole region. Okay. Okay, and likewise, this was an animation where we are gridding and coming up with temperatures at really high resolution scale as well. So, and we have a lot of sensor networks within our area. We are massaging all that information to come up with physics-informed machine learning algorithms to estimate street level temperatures. I'll give a detailed example in the next slide. I'm glad I put a high resolution map. So we are able to do these things because we have LiDAR scans for the whole city. And as you can see, I'm showing here the vertical cross section here. And if you look at this vertical cross section, I can resolve all the building levels. I can even resolve the light poles. And with this capability, I can provide the canopy structure. So canopy height, canopy coverage, as well as the crown height and everything. So we have that data capability, that data analytics to do these kind of mapping. And since we have that kind of resolution data set, this is like a meter resolution that we have come up with concepts like urban informatics. What we do here is we have street level observations where we have put them around the city. We use parcel level land use data set. We have LiDAR urban morphology. weather urban kind of a toolkits and machine learning algorithms. We are using Gaussian process regression models and combine everything to do street level forecasting. And this is just an example. This is the whole Chicago area, and I'm just showing a zoomed in version here that we are going to the street to that really high resolution scales and saying, okay, this region is relatively cooler in comparison to these regions. We take a step forward, we go and use GIS type of methods to overlay and work with cities to tell, okay, these are the areas where you should invest in planting trees. For example, these are the areas where it would not provide a lot of return on investment if you do that. So, for example, City of Chicago is aiming to put 75,000 trees in the next 5 years. They've already put 19 to 20,000 trees. So we can provide this kind of information so that they can make strategic decisions to where to put the trees. Okay, so this is like science directly making an impact on policy. We are also working on a lot of urban products and tools, and I'm doubtful if the animations will show now because I was hoping to show some tools, but we'll see. Oh, good, glad it's working. This one, this is we have the capability to look at these variations in a very three-dimensional way. Just giving an example here. But if you look at this example from a community sense of point of view, it's not useful. From a scientific sense, it looks cool, but we really want to go to the scales where it matters to the community. So we are doing a lot of work in those areas. So here, I was showing an animation where we were showing the shadowing impact of buildings, and it would have done on the fly. You could see if you make changes in the code, we would have shown how the temperature, how the shading impacts the region. And here we were showing the WRF temperature data at street and building scale. So we use 1 kilometer WRF kind of simulations and then street scale modeling. How do we go and massage at different scales so that we can, as you zoom in, like you do on Google Earth view, right? You see different features at different resolutions. So how can we create a scalable toolkit so that based on what your needs are, you see different products? So hopefully, yeah, so here, for example, this is at regional scale. We are showing some animation, and this is at building scale at much higher. This is a 200-meter resolution. So if you want to make, and we can even go higher. We are trying to create a forecasting toolkit so that we can do a forecasting to the scale in which our computation capabilities allows without using a lot of processes. So we can go to whatever resolution that we want. And then combining these things at these scales. So how can you zoom in and zoom out at different scales so that you can use those products at whatever to whatever questions you're trying to answer? And then combining these with socioeconomic variables like income analysis, demographic information, where different people lives, redlining, combining with heat vulnerability, and how do you massage all this information in a package that becomes useful for people and stakeholders to use it? So that's what we are trying to do. And this effort is funded by NASA, where we are looking at environmental justice through an environmental justice lens, these kind of issues that impact communities. I can't progress.
Anything outside? Anything outside?
Yeah. So this is a work in progress, and just showing you a conceptual framework where we are using observed data, WRF and WRF-CAM kind of simulations, census data, demographic data. This is kind of a toolkit that we are trying to develop, and you'll have something similar that you have for the air quality forecasting system, and we have correlations and then eventually to help decision making. Maybe I'll present in this mode. So yeah. So this is a spatial viewer. We have an interactive map to explore meteorology and air quality and demographic variables. Here we show temporal view to show interactive line charts to explore data over other areas. Users can select the fields that they want to explore The charts will be updated with observed data so that the user can compare observed and predicted data. So we have a lot of observations around this area. So we want users to click there and compare with the site to see how well are we doing with respect to forecasting. Of course, there will be biases, but that would provide a lot more trust in the things that we do. Okay. And then finally, we will have a statistical viewer where we are going to talk about interactive heat metrics and scatter plots to compare and observe data and forecasts. I hope I should be able to progress now because those were animations. Yes. So the overall goal is we want to provide a near real-time climate and weather products. So what happens over the last 7 days and what will happen over the next 3-4 days so that people can make decisions with respect to the activities that they want to do. So in addition, we are also working not only on heat and air quality, but related to flooding as well. So we have a high resolution coupled hydrodynamic model to visualize flood propagation at finer resolution. This is an example of riverine flooding. This is some early simulations over the Chicago area. And we have developed a framework to look at these issues, which is quite sophisticated, where a lot of in situ observations, crowdsourcing data, and dynamical downscaling is involved. So I'm going to give you a few flavors of few flagship projects that we have. This is our project with our utility partner, ComEd, which is an Exelon energy company, where what we are trying to do is they're very interested in helping and identifying where they can do afforestation. Okay, for two goals. First is, of course, they want to be prepared when the grid failure happens because of strong heat waves, and secondly is they want to help and serve the communities where their market is. Okay, so they're very interested in where they can plant more trees, wherever there is transmission lines where they should be able to put shrubs, and where high and tall trees can be planted. So what type of trees can be planted? And what we are trying to do is we are looking at future simulations and also the current simulation to really help them understand. And this is the development intensity maps that we have developed for 2030 minus the current almost 2020 year. And this map basically shows this is the area where we will see a lot of densification in buildings. A lot more built infrastructure will be built here. And on the fringes, there'll be a lot more new urbanization. And there are few places where nothing would happen. So we just don't want to put some trees everywhere. We are also very interested in changing the land use as we think about future urban climate change, so that is consistent with what the simulations would be. So making a little bit more informed decisions when we want to do these things. This is a project that we have here in Delhi, where we are looking at decarbonizing the transportation sector. And we see there's a lot of traffic congestion. We have a really poor air quality day to day. Heat waves really also disturb the public infrastructure. And then, of course, the air quality that becomes really bad. What we are doing in Delhi, we have just kickstarted this project is of course, the Delhi government, the Indian government is thinking of continuing the path of emissions till 2040 and then slowing the emissions down. What we are thinking is how can we incentivize sectors, private or public, to reduce emission pathways and see what are the trade-offs on public health and economic lens so that this can be implemented in a much fruitful manner. This is the map borrowed from with our collaborators at 400-meter resolution inventory. And these are the sites where we think, okay, we should have a lot more surveys and get more data sets, because these are the arteries which feed in a lot of emissions and traffic emissions in the area. And as you all know, the current air quality management program, the GRAP program, is basically right now, which is happening. High pollution alert is there, government reacts, alert passes, intervention lifted, and then you go in a cyclic manner. Okay, it's a very short-lived plan. But what we are proposing is, how can you measure air quality, including electric vehicles, transportation use and patterns? How can you use that transportation demand management kind of analysis? And how can we develop a framework where government proactively and continuous policy can invest in air quality measures? We are looking at more in terms of long terms, how those policy interventions can be done, and also understanding the human behavior aspect of this. How can we incentivize human behavior so that they can breathe much more improved air quality? So we are, of course, doing a very high resolution urban air modeling We are very interested in collaborating with IIT Delhi on transportation and human systems. And we have a strong portfolio and a plan on education as well. How can we design modules? And we just hired a person in education who's going to develop education modules, which would be some animated and some scientific, to think about, okay, how can you communicate that science to communities and to residents? Like the way, for example, in India, we had the Saksharta Abhiyan, right? So how do you go and tell people, okay, how can you incentivize communities? And then we are taking a very mathematical modeling approach where you combine the transportation and air quality coupled infrastructure systems. So we, for example, in a climate sense, when you perturb one thing, you can see the sensitivity of that on the climate model. But if you perturb a human behavior, how does that sensitivity, or a policy action, how does that sensitivity translate as a system? So we are very interested in systems approach to use these things. We would be making some headways in this over the next year, and I'm happy to share the results when we do that. Next is, again, transportation is an important sector. It accounts for 25% of emissions that happen globally. And of course, in the cities, we have established a new global center where we are looking at clean energy and equitable transportation solution. We call it CLEETS. And this is basically a roadmap that we have come up with, where we are looking at 3 thrusts: clean and equitable transportation, where we are going to look at travel demand management and clean energy and connected vehicles. Right now, the clean vehicles or electric vehicles will not be just electric vehicles, they will be autonomous vehicles too. So how do we use the user behavior and equitable fleet operations, develop emission trajectories and future emission projections? This is based on a lot on transportation and equitable modes of transportation. But we are very interested in the infrastructure as well, transportation energy infrastructure. What are the technologies, both in electric vehicle segment as well as in hydrogen vehicle segment? How do we develop a regional circular economy? So we are taking a very holistic approach. And of course, I'm an atmospheric scientist. We are really interested in climate change. And how do we do climate simulations of air quality and meteorology, climate transport vulnerability assessment? We talk about heat vulnerability. Transport vulnerability is also important. And also, how do you prepare road infrastructure to avoid road hazards, especially in Chicagoland and other areas during the winters? A lot of crashes happen. How do you account for those? And then all these things needs to have a decision support tool like the one we were trying to do it for air quality. How can we make those tools much more portable and scalable so that they can be used in other disciplines? We have deep interest in public health and economic impact, because as I said, every policy needs to have an economic or public health lens, otherwise they won't be able to make a headway. And when we are talking about new forms of technology, of course, cybersecurity and data science becomes important, because everything would be smart and connected, and then governments and governance and policy. So we are taking a very holistic approach, and we have faculty, almost 30 people involved here in this effort. And everything, as I said, for the Delhi as well, it has to go through a coupled infrastructure system. How do you perturb one thing so that you can see the impact across the ripple effect across the system? And we are going to do this analysis over the Great Lakes mega region, as well as South Wales and West Midlands in UK. And we have a lot of partnerships. We have a project in India, and we have other projects in Africa and Rwanda, and not just me, but my collaborators and everyone in the team. And our goal is to come up with, make this global center a really hub over the next 5 years. We are going to start working on this in January. We just got funded for this. And you can please go ahead and visit this website if you're more interested in what we are doing, to have more like-minded partners who are doing the independent research. We'll host yearly workshops through this. We have exchange program of students and scholars. We are happy to host them, happy to host our students if we are doing something on those areas, and then grow this. We have resources to do that. We want to grow this into a self-sustained ecosystem where people can exchange knowledge and ideas, as well as thrive this kind of center. Last is the Office of Department of Energy effort that we have called CROCUS. It's called Community Research on Climate and Urban Science. Okay, please do visit this. This is almost like $90 million effort from Department of Energy. We are funded at $25 million, and I lead the modeling effort of this project as a joint appointment at Argonne National Lab. We are led by Argonne, 12 academic and 4 community partners, 16 county, a big efforts over the next 5 years. We already completed year 1 in this. So this is an effort where we are looking at science in a much different way. Okay, so what we are doing is, this is basically community-driven science. We went to communities and say, we have a flooding problem in our community. We are going to deploy a heavy instrumentation there. We are going to understand the issues, develop models at those scales, and then upscale those models over the city scales and regional scales. So this is basically providing a blueprint for the cities to have a systems-based approach for integrated physical, biological, and human dimensions of climate change. We have agent-based models here. This is a framework to simulate and evaluate impacts and feedbacks between climate and urban systems. And it's a very integrated approach to look at social justice topics. If, as a atmospheric scientist sitting in this room, you might be interested in this slide, where our modeling is very sophisticated. At street scale, we are using OpenFOAM, NEC, RS, machine learning, AI, LiDAR, urban representations, and urban solutions. Few of the things I just showed in the previous slide. At neighborhood scale, we are using BAM kind of urban canopy. We are doing a lot of enhancements at that scale, model enhancements. We are, and also a lot of capabilities that we are developing that will be provided as open source as well. But at regional scales, we have DOE models, and how can we translate these kind of information in a DOE model so that they can eventually be included in the global climate models as well. So we have a focus on multi-scale simulations, as you can see, hypothesis-driven. Communities are defining the scenarios, right? Communities are involved in our weekly and bi-weekly meetings. When as a group in trust areas that we talk, we really have to tone down what we talk about, so that they can understand. At the same time, we understand their needs, and they understand at times the limitations that we have, which at times communities don't value or don't think that we don't want to work. When they sit with you in every meeting, they know, okay, these guys are also working hard, and we also start to understand their stress points and other things. There's a strong observational point of view, observational approach as well, and I'm going to give a few examples. At the same time, we have a strong citizen science component. So this is our observational slide, where we have the radars. These are our instrumentation being deployed at different places around the region. And right now, for example, last 3 months back in the summer, we had the Canadian wildfire, and we were trying to measure and make sure we capture those. So the instruments are doing this. Now we need to make sure the models are able to capture, because instruments are there only as field campaigns for a short period of time. Eventually, the idea is the models to learn so that the models can be trained and used as after the instruments or the end of the project. Again, we are frozen. Yeah, so we also really have strong partnership with NOAA and NASA. NOAA and NASA did the aircraft campaigns, and they measured air quality and a lot of variables on the surface. And our group partnered with them so that we can make sure we can work as a collective much better, and then come up with a lot more robust solutions. So with this is my last slide. These are just short takeaways. We are really striving to make cities and communities resilient. Okay, that's our driving mantra and motto. We do a lot of fundamental research, applied research, translational research, and are heavily collaborative. My takeaways are climate change impacts are very disproportional in cities. We can't think of what happens. Of course, there are things which can be generalized at a city scale, but there are things that happen at a very hyper-local scale. We need to really understand them. And we need to really bridge the scale gaps between regional, local, and hyper-local scales. And we need to design tools. We can't rely on single tool. Okay, we have designed this for the city. We need to design tools for specific science questions and research needs. And of course, as you might have captured, one solutions can't fit. We need to have a diverse form of solutions and a mixed solutions. And as you can see, it's not just physical sciences or atmospheric sciences. We really have to work with social scientists, sciences, engineering. We're also thinking to work with arts and humanities, by the way, because history is written by them, right? How we have perceived past heat waves or disasters in the history related to flooding or cyclones here that are written by historians and geographers. So we need to really think about how do we include them as we think about making headways in this field. So we are really into multidisciplinary and multi-stakeholder engagements for actionable, research-based, and of course, cost-effective and sustainable solutions. We are very mindful of cost that is incurred if it is based on HPC requirements or high costly instrumentation. How can you use low-cost sensors in a very smart way so that you can have good outcome from them as well? So which is something we are learning as we go on. That's all I have. Thank you so much.
So we can take a few questions. देखना chat box में कुछ है क्या? Otherwise,
Want to use it?
Yeah, you can unshare and then go to questions. Any questions are there? Please check, Chinmay. Were there any questions?
नहीं.
Okay, so we can have questions from here. Anyone, any comments and suggestions, questions?
For the nice presentation.
Yeah, please switch on your mic and speak.
Okay, thank you for the nice presentation. So you showed some measurements from the Chicago International Airport, right? The temperature measurements. So these are from which instrument?
Oh, those are just the weather. So which one are you talking about?
With temperature profiles. This was a model or observations?
So there were a lot more, a lot of things.
No, the vertical profiles of the temperature. You showed there was an increase in at the airport.
Oh, that was just the model.
Model, right?
Model,
So
yes,
it's a
yes.
2-meter model. Or what was the resolution of your model?
So that was 1 kilometer horizontal resolution, but I think they're at 50 vertical levels.
The
Yes.
standard one.
Yes, they're at 50 vertical levels.
Yeah, because at one point you were saying that you need stronger convection. For example, the horizontal rolls or the vertical lifting should be high for the lifting of the
Yes,
pollutants.
yes.
But at the same time, when you are making the rooftops as green,
Yeah.
then you have the less chance the pollutants might be accumulated, right?
Yes.
So this is really tricky.
Yeah, so it is tricky. So that's what the message is. When I showed those, we aggressively converted everything. As I said, as a modeler, we aggressively converted everything to see total back of the envelope capacity that if you use this scenario, what will happen. So the learning from that was you cannot make a decision without doing an assessment of where you need to really put that solution. So you need to really identify the hotspots, and where the hotspot are, you make those you do those interventions. And once you do those interventions, then you should be able to see, at least in a modeling design, are these interventions. There are two benefits of those interventions. Then are those interventions having a localized benefit? And there's a high probability yes, the answer would be they will have a localized benefit. But what is the impact on the downstream and the upstream of those interventions? So there was an implicit message here that you need to be mindful of what you're trying to put. And the second was, you can't have only one solution. You need to come up with a mix of solutions. So when we use the photovoltaics, for example, if we had aggressively just used photovoltaics on a simple rooftop, I think the energy that the photovoltaics produces really heats up the buildings. So it was not producing a lot, it was not creating a lot of reductions in urban heat island effects. At the same time, not as much reductions in energy savings for the buildings, because it was producing heat, the photovoltaics themselves. So we had to lift the photovoltaics to some height and also have white rooftops so that there's some reflectance happening. So I think those kind of analysis were helping to make an informed decision of how and what you should plant and where you should plant, add.
One more question is, you choose Delhi as a test bed,
Yes.
and you see nothing stops Delhi. Last week it was 600, but everything was running. So communities are driving the science you are telling. So this would be really challenging also because, and then you see Delhi always experiences this episodes of pollution, and in the summertime there are strong thunderstorms, gusty wind. This will also might add to your.
Yeah. So yeah, we hopefully when I come next time, I'll have some results for Delhi. So we'll and maybe we'll like to see some collaborations here to really push that, because we can do so much, and maybe if we can have local knowledge, I think that would really help to make informed decisions. It's way different than you're a local in your area, you do those assessments and you can do much more better analysis. But I think that's why we are seeking a lot more collaborations locally here, so that we have access to good data set, because the results are also dependent on the kind of data sets that you have and you use. So as you can see there, we have really good data sets to validate our models. Okay, so we have our home turf advantage in some ways. So, and we are happy to contribute here as well, but we'd like to see, okay, if we have data needs, especially related to emission inventories, that we are having a challenge, that how can we have better emission inventories, because if we don't have better or really emission inventories, then we can't do not just a developed emission inventory. We are seeking at a ground level, because that will help us identify which are the sources of the pollutants, and then modify at that fundamental level, so that, because we are not just looking at the air quality simulation in a model, we want to provide those to our social science team who can think of human behavior and interventions in their models. So we are not looking for really refined inventories, but we are looking at that really crude data set, so that we can come up with those kind of models. So that's something we would like to have.
Thank you.
And we can contribute to hope, with the hope that we might be able to help address. I'm sure it's a difficult problem.
So we have Dr. Thara.
Hi, how are you?
Hi,
Good to see you.
Ashish. How are you?
Good.
Yeah, very nice talk.
Thank you.
And I just happened to be here. I was just wondering whether you have done some validations, especially for that land use change that you rooftop greening or no greening.
Yes.
Have you done any kind of validations with the observations? Because it is also to do with you have shown that there is a vertical exchange.
Yes.
Is quite significantly influenced, and the PBL heights are influenced, etc. So
yeah, that paper is published, so we have done validation.
Okay.
But what we have not done is the distributed solutions. So we started the field campaign last year. This summer we'll have an extensive IOPs, and that's when we'd like to do a lot more robust assessment. So we have done it and then published a paper, but that was very, to be frank, very basic comparison. But we would like to do a much more robust comparison, especially related to boundary layer, because when we talk about boundary layer, you need heavy instrumentation.
Yeah.
So we have done measurements near the surface, and our results were comparable, and we published that.
Okay.
But we have not compared with the boundary layer because we didn't have observations. We'll have this summer, and we'll redo these simulations to test our hypothesis.
Yeah. Actually, it's very important to do that, because whatever we see at the surface may not be.
That's why that paper is still in preparation.
Okay.
Boundary layers you might have seen.
Thank you.
Because we have done the simulations, we have to redo them now for during the summer.
Yeah, and it's very aptly you have mentioned about the informed decisions, because the science-driven decisions, and you are really making a difference in that respect. Very appreciative. Yeah, I think it was very so many wide range of topics you are addressing. It's really
that's our goal. When we think of urban sustainability, it's very holistic, and we are grateful and glad at the same time that we have a really collaborative environment where we have a lot of resources and capabilities from
Diverse.
different people,
Mm.
different organizations that
Diverse
yes.
fields of
Yes,
interest are
yeah.
coming together.
So we collaborate with engineering, physical sciences, computer scientists, and national labs and universities in the region to come up with a holistic vision and solution.
Yeah.
So,
Very nice. Thank you.
So we have one question from chat box here. Shall I read?
I can read. In Pune riverfront, development is in progress, removing trees on the riverside and concrete on the riverbanks and channeling kind of a river. I'm curious to know what kind of effect will it have from these kind of developments, which is presented as something to bring people closer to nature. What actions are being taken by scientific community which affect the regional climate? I don't know, unless you do some simulations, it's hard to tell. This could be a very controversial question too, I would say, because I think at times you have to weigh in different decisions, right? To when you're doing things. Of course, nature-based solutions, if you are putting concrete, it's always not always good, but the long-term, what's the trade-off that you're having and what's the vision, it depends on that. So it doesn't mean that we should not do urban development, right? So I don't know. I don't have an answer to it.
That's right. Next.
Anyway,
Yeah, Dr. Pai.
Yeah, it's a layman type question. Yeah, it's very interesting, and as I understand, is the impact of climate change, local impact,
Yes.
that get exacerbated by actually land use, land cover, and emission, etc. So as such, it's a very complicated. My simple question is that when you even do modeling or when you suggest a solution, you need a very continuous dynamic data. Even when you say land use, land cover, it's not only surface.
Yeah.
You go to 3-dimensional, and in between you are suggesting, a green roof,
Yes.
then solar,
Yeah.
and things going very fast.
Yeah.
It's like a country like India. In many cities, urbanization is so fast.
Yeah.
And sometimes within 1 year and all, things get so much changed.
That's true.
So whatever solution that you suggest today may not be valid tomorrow.
Yeah.
I'm, even that urban heat island itself will get changed. Its location
Right.
get changed. So how you tackle, as she said, it's consisting of so many aspects.
Yeah.
See, for example, urban flooding. When we talk about natural, drainage, artificial drainage. Even that itself, based on some assumption, it works all well. But in reality, what happened is that a lot of talking here and there, and ultimately, what complicated model that you do, how to come out of that. That will be the biggest challenge, I think. So, what do you suggest?
Well, I think everyone will make their progress, right? So modeling community they make their progress. Urban development people will do it. Migration will continue happening. So I think it's a chicken and egg problem, as we said. So you try to improve, but by the time you improve, something else happens. So at the bare minimum, we need some basic capabilities that we think is essential. Like if you want to look at urban flooding, at least you need bare minimum these many stations. And of course, as more development happens, you'll have to have, the science also needs to advance. It's not what we used to think 10 years before was the state of the science is not state of the science. What we are presenting today, thinking this is the state of the science, will not be state of the science next 10 years. So I think there is no certainty that you will say, okay, today what we do will be the hallmark of what the next for 50 years. I think it will push the science the same way the urban development too, right? So as you rightly said, what you see every 5 years, 2 years, new development coming up, right? So everyone is advancing. And I think that's why we have our jobs too. So once we figure out the solutions, I don't think we'll have our jobs. So I think it's a continuous process, and this is what advancement is. And I think we should embrace this as a challenge and work on it. And also the government and the agencies should keep supporting, because they can't think, okay, this effort is completed, now it's done and dusted. So it's a continuous evolution that happens. But I think there should be a focus of thinking, okay, at least we make some breakthroughs so that we create a new baseline, right? So it should be at least in some ways transformational, the work that we do that sets up a new baseline, so that we have established something from which we can try to see, okay, what from here on, if new development happens of new topics or issues emerge, how do we address those? And we are not able to still work on the older topics. If you think about urban heat island, it's been studied over 100 years, right? Or more than 100 years. Likewise in the monsoon, right? People have been studying monsoon for so many years, and still it's right. So and there is advancements happening. So I think it's a process, and if we can push the limit in every step of the way, I think it's good.
Yeah. See, my thing was to say that it's definite. We are not going to, 100% going to be successful everywhere.
Yeah.
But then what is the basis framework? Say, even when you talk about Delhi, what we minimum need, as you said correctly, you need a meteorological observations,
Yes.
high density, you need a emission inventory is necessary. Then what else, some few things which we have to come up with, at least, if
Yeah,
you are
I
not
think-
possible immediately within 1 year,
Yes.
let's say 5 years, 10 years, what we should plan. I think that is how we can, build up this
Yeah.
type of observation network or
Yes,
inventory.
I think that's a very good point. As a community of scientists or policymakers, there should be a concentrated effort on making sure at least there is some good baseline, right? Be it observations or models or in community input, and also collaborations. So there are institutional roadblocks that, of course, there is a science exists, but it's not being shared, right? So how do we unblock those roadblocks so that we can really make progress? Otherwise, everyone is thinking of pushing it a little bit, but not sharing how they did it, and not providing others opportunity to make sure that this is something that is good or not, right? So I think we need to break that social dogma a little bit, right? And institutional roadblocks, so that there's some open science concepts. I think that's, and I might be wrong, but this is what I feel, that if we can push that and break that barrier somehow, I think that would really help. In some ways, journals are forcing now. If you want to really publish in reputed journal, they'll not let you publish until you provide the data, right? Provide the models. So there is some effort from that lens happening. So yeah.
Right.
Yeah. So so there will be a lot of questions and this thing,
Just
but
a minute.
yeah.
There should be some questions from our young friends on the left, and
Yeah.
only one young friend on the right, that is Mr. Chinmay. Otherwise, yeah, I expect some questions from young friends.
Yeah, so thank you very much for the nice presentation. So I have just just two comments. First one means, because right now the machine learning or the artificial intelligence, so because you already told about that this automated vehicles will be used.
Is it on?
Yes, sir. Yes, sir. So how we can use the artificial intelligence or machine learning in these approaches. And second one means if we will show the impact of our economy, because if we will add what will be the effect of these urbanizations on our economy. So people can think about with more interest that how much we will lose if this will happen like this. For example, for the pollution levels at Delhi. So today I just read in the newspaper that these number of the working hours was lost due to this pollution. So in this sense, if we can do something, or we can
Yes.
from the outside.
So that's where our new focus is. That's what I said in the morning. That's why we are thinking to hire people in those areas who can translate the climate science that we do in terms of health metrics and economic lens, because when we go to decision makers, they understand that language. Okay, as a constituency, how many people will lose the job? How many people will suffer from diseases or health impacts? What will be the infrastructure losses in terms of public infrastructure or private infrastructure? Because those are the metrics that they use in their decision making. So I think the more we collaborate with social scientists, the better we'll have a lot more impact of the research that we do. Because most of the effort and the research that we do, or people don't understand, right? So how do we convey that in ways in which people comprehend? So that's an answer to this. The second question on the machine learning and artificial intelligence, it's a very dangerous and very interesting field at the same time, because this will really provide useful information if you provide it a lot more useful data, right? So you need to have a really good training data set to have good training, good outputs. So if you provide bad input, the output might be poor as well. So we have to use those kind of products with a lot of caution to make sure that these large language learning models, LLMs, or physics-based informed machine learning algorithms in our domain can provide much more useful information. So there needs to be, frankly, as we also work in that area, a lot more scrutiny and we need to be very careful as we use these methods and scientifically robust so that people can use them. Yeah, there's a lot going on in this domain. Yeah, on the policy side as well, how machine learning and AI is entering our lives. Thank you.
Yeah, Mike, thank you for the good presentation. All these things. Actually, Mike,
Thanks.
Mike. Sir, actually, I'm just continuous for the question from the. You have to put that this roof top of that green vegetation, all these things. Basically, it's hitting all these things. But how is the winter time? How that affect all these things, and how the impact on this pollution? Because actually we can see that we can show your presentation also when we put that rooftop for the greenery, this boundary layer height also less.
Yeah.
And how the impact on the pollution, all these things.
So yeah, I showed that, right?
Increase the ozone level here also.
Yes, so the ozone levels.
That impact also there. And
yes.
How can you choose that greenery part of thing for summer and winter time?
So winters we have not done work yet. So we have not. This is what we have done. So I don't know what the impacts would be in winter. Winters in our region are very harsh.
Yeah.
So it snows everywhere. So, but there would be impacts with reflective roofs over the winters, because that's painted white and that has different albedo or sensible, shortwave radiation impacts. But I don't have a comment on how green rooftops behave, and because I have not worked on it. So something we'll explore.
Thank you.
I think we can discuss with more. A lot of questions are there for you.
Sure.
But time is little short. So Anand, I'll request you to please. In fact, he is here for some more time.
Sure.
And just before we take comments from DG sir, that actually urban meteorology in IMD is very young. A few years back, DG sir only established a unit for urban meteorology, and we also did a lot of work on LULC using the BUDAT. So more than 50 cities we have completed for LULC at 30-meter resolution. We prepared all India LULC at 100-meter resolution. That we have provided to NWP division, and they are using it for their modeling purpose here. And trying to initiate this urban models also, work model, and using urban processes in WRF models. And at high resolution, we are trying to run those things. So there is a lot of scope to work with you actually, and a lot of things to there we can get from you. And but we'll discuss more.
Sure.
And I'll hand over to DD sir for final remarks, questions, and
Sure. Thank you.
So thank you, Dr. Soni. So on the behalf of India Meteorological Department and my behalf, I extend heartiest congratulations to you, Professor Sharma, for this excellent presentation. And I'm sure that all the participants have gained a lot with respect to the basic fundamentals of urban meteorology. You very well started with the basic concept, urban meteorology, and gradually went on discussing the various concepts, various components contributing to the urban affairs. And also you discussed about the various types of modeling systems needed, not only at present, but also for the future, the role of data. Also you discussed about the sustainability and how the science of urban meteorology can be utilized for policy planning. And very interestingly, you also brought out that how the social science can be integrated with the science of urban meteorology. A role of historians, even you discussed. So all these things have given a new outlook, perhaps, especially for our youngsters. Even I myself learned a lot from your lecture. And moreover, I want to congratulate you and your team for excellent work on urban meteorology.
Thank you.
Which is really global in nature, which is a frontal science, and which will open the eye of many countries and many urban agglomerates to take off it on real time. As Dr. Soni told, we are really very nascent in this business or in this science. We just started urban meteorology unit in IMD few years back, and we are coming up with some basic information about the various urban areas of the country. At the same time, we have also a plan and progress, and Minister of Earth Sciences also a plan, and Dr. Tara is also dealing with the urban meteorology from IITM and the ministry. And today itself, she is here to plan with the urban meteorology in Delhi. So ministry is coming up with a very big project for Delhi, especially with about 200 automated stations, automated rain gauges, LiDARs, as you told, and radars, all these sophisticated instruments. Perhaps your lecture, your interaction, your contribution will help us to sharpen our plan and project for Delhi. And whatever work we have done and you have planned, that also can be integrated, can be complemented. We can work together.
Sure.
The most important work what we have highlighted is the collaboration. Collaboration is the key to success. As a meteorologist, I will tell you so far, whatever success we have seen, it is because of the collaboration within ministry, all the associated organizations, and also the collaboration with various national and international agencies. So certainly the collaboration helps in sharing the knowledge, sharing the data, sharing the experience and expertise. So we need a very intensive collaboration with you and your team.
Definitely.
And so that as the son of the soil also you can contribute, and also we can benefit from your initiative. So therefore, there should be a mechanism for regular interaction with your team and our team. And we should meet in various fora. Otherwise, electronically we can meet and we can carry forward the aims and objectives to fulfill the strategy. We can sharpen what we have done actually. And Dr. Pai has raised a very good point. I will tell that what I feel the solution is that you need rapid updating of the data. So geospatial data needs to be high resolution. It has to be upgraded, updated more frequently.
Yes.
At least once in a year, we should. But I will tell you, we have done some solution for cyclone, where we have kept the provision for updating the data twice in a year. One in month of March, another in the month of September. And that data has to be provided by the state government, be it the drainage data or be it the other dam data or whatever it is. Similarly, when you go for rapidly improving the urbanization structure and characteristics in India, maybe once in a year will not be sufficient. You have to go for at least twice a year or every quarter, whatever it is. So that type of mechanism is possible only if we have a strong coordination, cooperation, collaboration with state authorities and urban authorities. So therefore, a complete setup has to be established, and we have to convince those people to be part and parcel of that. And they can be convinced only if they see some light instead of in terms of the benefits. So just like you have discussed the short-term benefits for Delhi and long-term benefits, what is needed to be done. Similarly, that is one aspect with respect to pollution. When Delhi, they will be worried about. But they will be also worried about the weather patterns, like, say, for example, flash floods on the day of G20 meet. And it did not rain, there was no heavy rain in Delhi anywhere, but it was heavy rain on that Bharat Mandapam. That was heavy rainfall activity. There was a flooding. So therefore, we have to take into consideration, and nevertheless, what Shravan told, that there could be the thunderstorm activity. Also, so Delhi also experiences thunderstorm activity, especially pre-monsoon season. And there are also activities during the winter season. There will be a lot of western disturbances. Sometimes it causes some problems for all sectors, including transport sectors and the power sectors or energy sectors, you can say. So therefore, it has got a lot of implications, and study will be very useful. That economic conversion of how much is the advantage, that is separate issue that can, but it is visible. It can help economically, socially,
Yes.
and it can help not only on the real time but also for the future. So that is well understood. Only thing is that now we have to strategize, we have to plan, we have to take off the various interventions in terms of enhancing the meteorological observations, enhancing the specific observations for the urban area of Delhi, identifying the hotspots, whatever it is, based on the past data, or identifying the, you can say, vulnerability and hazard and impact. At the same time, modeling. You have gone up to the state level modeling. So you have to go for state level modeling. I think in our Vision 2047, they might have mentioned the state level modeling, but already people are working on state level modeling. So therefore, we have to enhance our approach and activity. How can we improve our modeling system? Especially taking a pilot study, for example, Delhi. Afterwards, we can think about other cities. So we have to go for okay, it is just like cascading process. You have to go for global modeling, already it is there. You have got regional modeling, it is already there. Then you have got non-cost modeling, it is already there, which can be further improved. Then you have to go for further regional modeling within the city, that is city scale modeling. Then you have to go for the street scale modeling. So this type of modeling setup we should plan, and we should bring out in the country at least within a year or so. Planning at least should be complete, and whatever the requirement for that, you can say DPR should be ready for that purpose. We will need your help and intervention for that purpose.
Yeah.
Then, of course, you need some kind of decision support system. Yes, we also plan some conditions. I told Dr. Soni that we should have a decision support system. Whatever we have, utilizing weather, utilizing air quality combinedly, because both are related. You cannot have air quality decision support system separately and weather decision support system separately. You should have an integrated decision support system to take into consideration all aspects. They are interacting, and every time when the weather is occurring or whether the air quality is improving or deteriorating, all are integrating with each other. So you have to take into consideration. Therefore, a very holistic decision support system has to be developed, and people are working towards that direction, but it can be improved further. Then comes the capacity building. You need capacity building. People need to work on urban meteorology. So more and more people should work on urban meteorology. IMD may not have, but you have to form a forum of urban meteorology where you, within the ministry and also outside from different academic institutes, the young scientists and engineers can be part and parcel of that. That also should work towards Dr. Soni and your team, we have to, Dr. Pai. So towards that, we should have some kind of forum where people can contribute. At least we should know what progress is going on. There should not be a hide and seek mechanism so that X does not know what is going on in Y and Y doesn't know what is going on X. So their transparency and sharing of knowledge and experience and modeling system also will go a long way if we can have that type of forum developed for that purpose. Then, of course, interaction with the social scientists, interaction with and the authorities, decision makers, and planners in the urban areas. That should be also taken up simultaneously, so that some kind of inclusiveness is ensured, number one. And the other one is that the ownership. The urban bodies also should own it, the science or the conversion of the science to the society, that should be owned by the urban bodies, and accordingly action is being taken. So these are some of the components what I understand from your lectures. Thank you very much for this excellent lecture, and we will work towards all this direction. Thank you.
Thank you.
So we can have photograph here, and I just want to, we want to felicitate you.
Oh, thank you.
Yes. Yes. Madam, auntie, hai na? Mother?
Yes.
We can call mother also. Madam, please come. We are proud of Ashish ji, we are proud of you.
He has a visa.
Yes, yes.
Okay,
So, yeah.
सुनिएगा फोटो ले रहे हैं थैंक यू सो मच नमस्ते मैडम you can have photograph, do photograph. Please come. आइए मैडम आज I think we will go to the front. Some people can come. Madam, आ जाइए, सभी आ जाइए.
आ रहा है सब आए?
Yes.
Thank you.
Thank you.
Thank you. Sony.
Yes.
Can you close the meeting?
Sure.